Hey, what's going on, everyone? So we're going back to that job where I did the fuck was that? Okay. Where I did the igniter for that pool. It's not a callback. We're doing something else in that same house. Customers like never there. They're always down like somewhere else during the winter, so they're not even there. But there's a Taco zone control that needs to be changed out. So we're gonna take a look at that and see what exactly is going on. Change it out. I'll explain how a Taco panel works and what it does, or how it's supposed to work, how it's supposed to be wired and things like that. So I'll see you guys when I get there. All right, so we're here again. I had to park all the way over there just because you can't drive through that specific part of the driveway that they're fixing. So I have to come here. This is the zone panel we're going to be replacing right here. So I got to figure out, am I going through the back or the front? We'll call the office and see. All right, I'll start shooting back when we're back inside. All right, so this particular call, the customer had his electrician look at the zoning panel for the boiler system, which this is a Bradford White K2 tankless boiler system. You can see right there, it is a tankless boiler system. I'm sorry, not tankless, a high efficiency wall hung boiler system. It's got, this is actually part of a geothermal system as well, but we were worried about the zone panel down here. So anyway, there's just a lot of wiring, a lot of this guy right here acts like a primary secondary controller. So this actually regulates the temperature because they have some radiant zones in the system, which I have to take a look to make sure they're alternating correctly. But yeah, it's opening and closing the system. Hopefully it's working correctly. But anyway, this box we replaced right there. So basically, this guy right here is the old box. You can see that it's got some discoloration here. His electrician, customer said his electrician without any tools, without anything, determined that the transformer was bad. He wasn't wrong, right? The transformer was bad, but if you take a look here, there's an inline fuse right here. This fuse was actually popped. Now I'm not gonna it's gonna be really hard to see, but the link is broken on this actual fuse. So the fuse is bad. Now in here they had a bunch of different stuff overloading the system. So they were powering this external zone panel right here. They were powering this common maker for a Google thermostat. They were powering these two other sources of 24 volts. Like, it was just a lot for that one transformer. So you can't necessarily do that, because then what's going to happen is these transformers are only rated for up to 15 VA. So like these transformers, I don't know if you can tell, like right there, you'll see the rating. They're only rated for up to 15 VA. So you can't necessarily put in a bunch of different stuff in the transformer, because then eventually what's going to happen is over time it'll just put way too much stress on it, and it'll just thermally just break. The windings will just overheat, break, the transformer will be no good. This particular panel, it is a Taco switching panel. So on the top you'll see your low voltage terminals. So these are all your thermostat terminals right here on the very top of the system. So you got to make sure that your thermostat corresponds to the appropriate pump on the bottom here. On the bottom you have all your high voltage systems. So this is all your high voltage pumps. So this particular one is a SR503 switch and relay, and this controls pumps. So you can see right there, this controls circulator pumps. So the triangle there on the bottom, that is signifying that it controls a circulator. That's actually the generic symbol for a circulator. So if you ever see a triangle like that, that's just referring to a circulator pump. So right now we have two zones calling for heat. We have the high voltage terminals here on the bottom. They're actually energized based on the call for heat right now. So basically this guy, you have 120 volts coming in, and we transfer 24 volts out to the top portion. The top is low voltage, the bottom is high voltage. So based on each individual thermostat call, the appropriate zone pump will trigger. So that's kind of telling you, hey, okay, so zone 2 is calling for heat. Zone 2's pump is going to start to circulate that hot water. So I rewired it. Like, it was actually a mess in here. It looked quite bad. But there was a lot of wires just all over the place. A bunch of stuff bundled up over here. I'll see if I can edit a picture into it of the before, and then you'll see what I mean. You can technically, this particular Takeo board right there, it has a 24 volt, like you can see 24 VAC, and in the bottom it says COM for common. Now you can steal power from there, you just can't steal too much power from there. You have to make sure that whatever you're stealing from is not going to overload the current transformer system. That is why I placed a secondary transformer down here, which we power off the same 120 volts coming in. So we have the same, all these are all your neutrals right here. On the back of that I have all my hots, but this is all your neutrals. So you have power coming in from a switch over there. You see that white wire here in the bottom? That's your Romex wire connecting to a switch on the other side of this boiler, which is main power coming in, which is going to feed your box right here on the right hand side where it says neutral and hot for 120 volts input. That is the power coming into the actual box that is then going to transfer power to everything else. So 120 comes in, it goes over here, it hits this guy, and then it goes and distributes 24 volts on the top, and it powers your 120 terminals on the bottom. Now you also have to power 120 volts on this on that controller right there. So that's all powered up. So yeah, so right now we're just kind of making sure the system is operating and firing, and then we'll just make sure that everything's good to go and tested. But yeah, any question on the Takeo switching relay? Like I said, it's pretty self-explanatory. You have to make sure that whenever you're replacing one of these or you're doing one of these, you label everything and you are as thorough as possible, because if not, you're gonna find yourself in a kind of a nightmare scenario when it comes to wiring. Again, depending on what the situation called for, you might have to actually start doing continuity tests and look at where the wires go and what do what. Because sometimes, like I said, a lot of different people, if you're not the first technician on the job site, you're gonna have trouble figuring out what's what. If you've never been to the job site, or you're not familiar with the system or anything, just make sure you label what supposedly is what in the system, and that'll give you a better reference when you're rewiring everything back in. So you're not having to find out, oh, what thermostat controls what pump or what does what. And that is why I actually carry different tapes here. So I just kind of label everything. But let's make sure that this boiler is operational. It's running at about 146 degrees. Central heat is on. This is the switch that I was referring to that transfers power to everything else over there. Yeah, but look at that. Ooh. Yes, especially doing your shark bites on heating lines. This primary pump is running. Wait. Yeah, primary pump is running. Oh yeah, no, we're moving water for sure. That's gonna be my return, right? That's gonna be supply, because we're pumping. Let's see, I can't see if we're pumping up or down. Oh no, we're pumping. There we go. Arrow, we're pumping this way. So that's my supply, pumping out. It's a mix. It's gonna be a mixing valve, yeah. Because you can see it's tied into the return line. It's going to the supply. That's a mixing valve, so it helps regulate water. This is probably a radiant system. If I was to take, yeah, it's a radiant system. Yeah. Yeah, it's gonna be a radiant system. Oh, it's got the old. Oh, that black tubing right there. That's actually non-oxygen barrier tubing. There's been a lawsuit on that tubing and everything. That's not good, because that tubing forms a lot of debris on the inside of that pipe. That's very bad. It has no oxygen barrier, so you get a lot of issues with that. Like those guys right there will clog up a lot, actually. But yeah, so we'll test it out, make sure that it's still operational and everything's good. We'll put the cover back on. Then it takes a moment to put the cover back on into the dome. Alright, so that's done. That's done. Well, and now it's cleanup time. Yeah, hopefully you guys enjoy. Like and subscribe for the video for more. We'll try to get as much information as possible out to you guys. Yeah, I'll see you in the next one.